Now we're going to look at anomalies in the troposphere. An anomaly in the troposphere is going to be an inversion or a temperature inversion. What that means is this, that instead of increasing altitude resulting in decreasing air temperature, increasing altitude results in increasing temperature, the opposite of what we would expect. If you had a glass and you flip it upside down, you are inverting the glass. This is where the terminology comes from, a temperature inversion, because it's the opposite of what you would expect to happen. There are two types of inversions. Low level, also known as lower level inversion, and upper level inversion. Basically, the names tell you where these two types of inversions are going to occur. We're going to begin with the low level inversion and then come back in the next video with the upper level inversion. With the low level inversion, what happens is this. These occur at the surface, hence the name low level inversion. So in other words, they are going to happen in contact with the ground. They occur on long, cold, clear, calm nights. Let's think about this for a moment. What time of the year and what conditions are we looking at? Long nights. When is that? Winter. Cold nights. When is that? Winter. Here's the reason for clear and calm. If you recall, the presence of clouds at night will keep temperatures warmer than if there were no clouds. To make a low-level inversion, we want maximum surface cooling. That's going to happen on clear nights when more long-wave radiation can escape the lower atmosphere and reach the upper atmosphere and then potentially go out into space. Calm nights because winds cause mixing of the atmosphere. We talked about this with water, how water mixes. The atmosphere is actually a fluid body, something like water. It's just not as dense as water. When water mixes, you're moving around warm and cold waters, and what that does is further transmits the heat energy from the sun. With the atmosphere, when there's wind mixes warm and cold air. We want calm nights so that the air can lay in contact with the cold ground for the maximum amount of time. On long, cold, clear, calm nights, the Earth's surface gets maximum cooling. The ground, of course, continues to lose long waves all night. You know that the surface of the planet is never going to reach 0 degrees Kelvin. And as long as something doesn't get that cold, it continues to radiate energy away from its body. Well, on long nights, the Earth is losing long-wave radiation, and that is not replaced until the sun comes up. Therefore, if we can have very long nighttime periods, we are losing maximum amounts of energy off the surface of the planet. When anything loses energy, it cools off. Because of this, the ground temperatures drop. The ground is losing long-wave radiation that is not being replaced by short-wave radiation. The air, our atmosphere, takes on the characteristics of whatever it's over, which means that if the air is lying over the top of something warm, it gets warm. If the air is lying over the top of something cold, the air will become cold. Cold ground means cold air in contact with that ground. But it's just the air in contact. I would compare it to this. If you took your hand and you put your hand, the palm of your hand, down on a block of ice for about a minute, what's going to happen? The top of your hand isn't necessarily going to cool off, but the surface of your hand is going to get very cold because it's losing energy. A similar thing is going to happen with the atmosphere. On a long, cold, clear, calm night, when the ground can have maximum cooling, the air that's lying over the top of that ground also gets very cold. But the air above it 50 feet, 100 feet, 1,000 feet remains as it would normally be. Take a look at these two diagrams here. Over on the left-hand side, what I want you to see is normal conditions in red. Notice that if that's graphing temperature as you increase altitude, this is what normally happens in the troposphere. Increasing altitude results in decreasing temperature. You can tell the temperature is decreasing if you look at the graph along the bottom. As you go to the left, temperatures are going down. And that red line, as you get higher off the surface of the planet, is going to the left, which indicates that temperatures are dropping as you increase altitude. Now, if you look over on the right-hand side, you can see what's happening. I've removed the red line, is this. Because that's a long, cold, clear, calm night that's being depicted, you can see it says cold surface. Notice that the air that's in contact with the ground is very cold. And as you increase elevation away from the ground, air temperature is actually going to the right, which means it's warming up. Can you see that? Right there. That is the low level inversion. It means that along the surface of the ground, the air is cooler than the air above it. But you can see you reach some elevation and then everything goes back to its normal conditions, which is decreasing air temperature with increasing altitude. Again, I would compare it to putting your hand on a block of ice. Your entire hand doesn't cool off, just the area that's in contact. This is what happens to the atmosphere on long, cold, clear, calm nights. The air in contact with the ground, it might only be 10 or 15 feet, cools off. Now, there are circumstances where there's a visual manifestation of this. In other words, you can see it. Most of the time, you cannot see low-level inversions, but there are times when you can. I was jogging in the park down the street from my house a couple of months ago. I happened to have my phone early in the morning, and you could see that there was a fog lying over the top of the ground, but you can see above that, you can see the sky as the sun is rising. That fog that's lying on the ground is a visual manifestation of the fact that at night, over the top of that park, there was indeed a low-level inversion. Same thing here. I was driving in Wyoming very early in the morning. It doesn't look early in the morning, but it's very early in the morning. And you can see what's happening. You can see that very, very low-level fog that's touching the ground. That is a visual manifestation of the fact that there is a low-level inversion occurring.